All right, so let's get started by wrapping up what we didn't get to do yesterday. So if I recall, we made it through interpreting the IQR, right? Then we stopped before outliers. All right, so this is kind of the moment that I've been alluding to for the past couple of days. Because in the graphs, haven't I always used kind of the term potential outliers? Because I said the math was going to come later to officially determine if something is or isn't one. So that's where this comes from, okay? 1.5 times the IQR rule. And that helps us to give firm numbers, firm evidence if something is an outlier or not. Now, I'll say all of my numbers are erased from yesterday. So can somebody remind me, what was the IQR of that McDonald's data? Was it 20? Yeah? Okay. So that's going to be the first thing you need. You need that IQR. Okay? And now it talks about 1.5 times the IQR rule. Okay, so what that means is we're going to take the lower quartile and we're going to subtract off 1.5 times that IQR. What was this? Was it 19, if I recall? What was the quartile one? Can somebody check really quick? Is it? Yeah? Okay. So this will determine if something is a low outlier, okay? Now let me pull out a calculator really quickly. So 19 minus 1.5 times 20, and that gives us negative 11. I don't think there were any sandwiches with less than negative 11 grams of fat, right? That wouldn't really make sense. So are there any lower outliers? No. And then we do the opposite. We start at Q3 and we work our way up. Was Q3 39? So 39 plus 1.5 times 20 gives us 69. And again, is there anything above 69? Were there any data points above it? I don't think there should be. So this data set actually does not have any outliers. What this rule does is it kind of sets a window of reasonability. Anything within here is considered reasonable. Anything outside of this range of values, anything beyond the negative 11 or beyond the 69, those are what would be officially deemed as outliers in the data. So again, this one just doesn't have any that we have to worry about. Okay, so again, pretty easy rule. Just takes a little bit of mastery to remember precisely what those calculations are. So let's jump into the multiple choice, get through that, and then we'll get to today's stuff. So which of the following statements about this distribution is not correct? All right, so we're looking for something that is not true about this distribution. So A, the histogram is skewed right. True or false? True, but ironically that means it's not what we're looking for, right? We're looking for the false statement. So here A, not going to be what we want because it actually is true. The median is less than 20. True. So if we take this 136 divided by 2, that would give us 118. And I think the median is actually... whoa, what am I saying? Oh my gosh. No, it would be... yeah. So yes, I'd say that is true. The IQR is 35. Okay, can we see that from here? No, I mean, technically IQR is Q3 minus Q1, but again, with a histogram, we can't even really determine that, can we? We can't precisely know what those values are. We can only kind of get a range of those values. So I would be very hesitant to say C is true, okay? Simply because we really don't have the toolbox it takes to figure that out. So I think C could very easily be what we're looking for as the false thing, but what should we continue to do? We should still check the others, shouldn't we? We should convince ourselves the others are true. So the mean is greater than the median. Well, that's something we talked about yesterday, right? Looking at the shape of something can give us an indication of what's happening to the mean. Isn't the mean going to get pulled by the tail, pulled by the outliers? So wouldn't this actually be true? The mean is being pulled up compared to the median? And the histogram is unimodal. Okay, I think I brushed on this the very first day, and I'm like, you never really have to use this if you don't want to. Doesn't unimodal just mean a single peak, right? Does that have a single peak? Yeah. So yeah, C is the only thing we can't completely convince ourselves is true. 40 students took a statistics examination having a maximum of 50 points. The score distribution is given in the following stem and leaf plot. The third quartile of the score distribution is equal to, all right, so here, third quartile. Well, isn't the third quartile where you take the median and then you find the median of the upper half of the data, right? So couldn't we do that here, especially since all the data is in order? So 40 kids. So wouldn't the median be between the 20th and 21st data points in order, right? Halfway between them. So let's look first where the median is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right. So the median is going to be 32, right? The median is going to be right in the middle of those two numbers. And then, don't we do that again? So now we have 20 values here. So now the median of this part, wouldn't that be in between the 10th and the 11th within that upper half? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what does that upper quartile end up being? 44. Excellent. Two distributions, D1 and D2, are displayed on the same graph. If the distribution D1 is skewed right and the distribution D2 is skewed left, and the mean of D1 is lower than the mean of D2, which of the following statements is not true? All right, so this is a lot to take in. I think the easiest way for this one, I would draw a sketch about what we're looking at. Okay, so we have this D1, which is skewed right. So doesn't D1 look something like that, right? D2, it says, is skewed left. And we also know that the mean of D1 is lower than the mean of D2. Okay, so here, let's say the mean of D1 is right here. Mean of D2, let's say, is right there. Which of the following statements must be true? Well, by knowing this, so if we're just looking at D1, wouldn't this mean be being pulled towards the tail? Right? So in relation to the mean, wouldn't the median of D1 have to be less than that mean? Can everybody see that? We don't know exactly where it is, but we can put them in relation to each other, can't we? We know that median is going to be less because the mean is being tugged by the tail. Well, here, if the mean is being tugged this way for the green distribution, wouldn't the median be somewhere up there? So again, we don't know exactly what they are, but we do have a very distinct order to these four things, don't we? So which is the only thing listed here that is not true? Looking at that order that we just created, which is not true? Yeah, I would say I'm seeing C. The mean of D2 lower than the median of D1 is not true. Everything D2 is greater than anything of D1, right? Of those two elements we're talking about. Any questions on that? I'm hoping as you see it, it makes sense, but I think doing that one alone would obviously be a little challenging at this point. All right, and I think this is the last one before we get to today's stuff. The mean weight of a group of 100 men and women is 160 pounds. If the number of men in the group is 60 and the mean weight of the men is 180, what is the mean weight of the women? All right, so we want the mean weight of the women here. So overall, there's 100 men and women, and overall, there's 60 pounds. However, the 60 men weigh 180. Okay, so let's take a look at how the formula works. So overall, their weight is 160, right? Overall, we can say that. So here, we have the 100 people total. And now we know we have 60 men weighing, and their average is 180. So total, isn't this what the men would weigh? Right, kind of going off how we did this yesterday for the example of my AP stats classes. Plus, how many women are there? If there's 60 men, how many women are there? 40. And then isn't their average, the average of the women, isn't that what we want? So by setting up this formula, am I able to find what I need now? Yeah. All right, so talk me through the algebra here. Again, I'm hoping the algebra is the easy part because I know all of you have had that before. What would the algebra look like to figure out what that average weight is? Multiply the 100. Excellent. All right, and I'm sorry, what was the next thing you guys said? Subtract it, love it. So that's 16,000 minus that 60 being multiplied by the 180. So I just subtract this whole thing over, which leaves me 5,200 equals 40W. And now what was the last thing again? Divide by 40. And there you go. Right. Any questions on those multiple choice? All right. Then let's dive in to the new stuff for today. And again, I apologize. I know this means we're going to spill into tomorrow again. But the review days never take the whole time. So I think we'll still be okay to keep on track. So today, the first thing is just going to be kind of reviewing a little bit of what we did yesterday and then how that applies to making a box plot. How many of you guys have made box plots before? Are familiar with them? Okay. So, for box plots, something you're going to hear often is something called the 5-number summary. Now, the nice thing is there's nothing new in that because every one of these pieces, didn't we talk about yesterday? So that's why I shoved a little bit of extra stuff into yesterday so you'd already have that background so today would be easier for you. Okay, so you already know how to make the 5-number summary. So let's review really quickly with how to do that here with Hank Aaron's distribution. So here is the number of home runs that Hank Aaron hit in each of his 23 seasons. So the two that are really easy are obviously the min and the max, because isn't that just the smallest and the largest, right? And then what's the next one that we find? We don't necessarily find these in order, do we? What's the next one that we can find? The median, yeah. So when you're finding the 5-number summary, first of all, you could just plug this in the calculator and away you go. I showed you how to do that yesterday. Or here, you can do it by hand, but you're going to find the median next. You can't find the quartiles without the median. 23 things here. So that would mean that the 12th thing is what I'm looking for, right? 11 things here, 11 things here. That middle, that 12th position is what I want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, Q1. Don't we do that again, but only with the lower half of the data? So there's 11 things here, right? Which position am I looking for to find the middle of this lower half? What? 6th, yeah. 1, 2, 3, 4, 5, 6. And same thing with the upper half too, right? If I'm counting up here, 1, 2, 3, 4, 5, 6. So first of all, is everybody okay with that from yesterday? Yeah. And again, if all this fails, in this case you literally have the data, you can honestly just plug this into a list and the calculator could do it for you, right? But when it's already in order for you, it's just as easy sometimes to do it by hand. All right, now, the 5-number summary actually gives you every single piece you need to build your box plot, okay? So how we do this is, let's look at how far we have to stretch. Okay, so we have to stretch from 10 up to 47, okay? So I'm going to go from 10 up to 50, right? Easy enough. And then let's count by 5s. 15, 20, 25, 30, 35, 35, 40, 45, 50. Now, if I have time, I'm going to pass back all the stuff you gave me yesterday. But something I saw a lot of kids forget. So when I pass back your take-home quiz, if you see -1 and then label written, what did you forget to do for me? You forgot to label the graph. Okay, and again, that hit a lot of people. Okay, a lot of people did that. So you want to make sure, again, don't just build this graph and not tell me what it is. They're going to be looking for some sense of context. So here, aren't we looking at home runs, right? Number of home runs. It can be as simple as just putting that down, but I need some sense of label or title. Okay, you have to tell me what this graph is. Now let's go through and put in all of our numbers. So the min and the max are just dots, okay? So here, the minimum is a dot, and the maximum is going to be a dot, okay? The other three are going to be vertical bars, all right? So 26 is going to be a vertical bar, 34 is going to be a vertical bar, and 44 is going to be a vertical bar. Hence why they're called box plots, but sometimes you also hear them called box and whisker plots. Okay, because you kind of see that box in the middle, then the whiskers going off. All right. So let's Oh, whoops. Guys, spoiler alert, I accidentally gave you the answer to the next question. Whoops. All right, so here, describing it would work the same way, right? What are the 5 things I look for when I say describe a graph? Socks and context. Beautiful. Again, I apologize that I didn't hide this. My bad. But it saves you guys writing. But do you see how I hit every single piece of that here? The one thing that's a little bit more challenging to see is the shape, okay? Box plots are not the best in terms of showing you shape, but I think you can kind of see what's happening here. Do you see how this lower quartile is really stretched out? So isn't that kind of alluding to the fact that there may be a little bit of trailing off in the data back there since it's so spread out? One thing to keep in mind, okay, I think I probably note this later, but this is as good as time as any to bring it up. These have equal amounts of data within them, don't they? Didn't we evenly split up our data at 25%? So the length of the boxes here, the length of everything. This segment, the fact that it's longer, doesn't mean there's more data there. What it means is the data that is there is more spread out. Okay, that's a very easy misconception to make, especially multiple choice. I promise you, they will probably try to get you with that. But yeah, the length of every segment, all that represents is how spread out that information is. Every one of them has 25% of the data in it. Okay? So, here are the number of home runs hit by someone else, by Todd Klang. So what I want us to do is practice doing this in the calculator as well. Okay, if you need a calculator, come up and grab one from me. Otherwise, if you already have one, start typing this data in for me, please. You're welcome. You're welcome. You're welcome. All right, so again, let's practice. Where do I go to input data into a calculator? Stat, edit. Again, if you already have information there, if you scroll up, so you're highlighting the list itself, hit clear. Again, what you never, ever, ever want to do to a list, never delete it, okay? So, 8, 11, 14, 16, 17, 19. All right, and we want that 5-number summary. We want those 5 pieces of information. What calculator command that I taught you yesterday will get you literally everything you need? One variable stat. So go back into stat, over to calculate. We want it to calculate those one variable statistics for us. Okay? If we scroll down, here is everything that we need. Can you guys write this down for me, just so you can repeat it back to me when I switch back to my smartboard or smart notebook? Does somebody have it down for me? I do. Yeah, love it. Thank you. What was Q1 again? Median. And third quartile? 34. Beautiful. All right, now, something else to note about box plots. 99% of the time, so literally just do it all the time, is best if you indicate your outliers, okay? What that means is if you have an outlier, it actually does not connect with the rest of your box plot. It's going to be just a little dot off on its own, disconnected from the rest of it, okay? So I didn't address that last time because, spoiler alert, there wasn't one. Is there something here that might worry us? Yes. Does the 8 worry us? I mean, not really. There's a lot of data pretty close to it. What does alarm us? I think the 62, isn't there a very good chance that could be an outlier? So this is where you can algebraically check if it's an outlier now, okay? Isn't this where that 1.5 times the IQR rule comes from, or not comes from, is used for? So I'm not going to bother checking the bottom. I'm not really worried about it, but the top is something I am worried about. I am going to check those. So I'm going to take the third quartile plus 1.5 times the IQR. Well, I don't have the IQR right now, but it's easy enough to get. How do you find the IQR again? Q3 minus Q1. So 34 minus 16, wouldn't that give us 18? And let's check. So 34 plus 1.5 times 18. Oh, guys, look. There's an outlier. What a coincidence. So remember, anything above this value is an outlier. So here, that means that is going to be disconnected from the rest of our data, the rest of our whisker. So what I want us to do is now we can go back. Let's add in this data. Okay? So, I'm sorry. We actually have to extend this a little bit then. So the minimum was 8, right? So I'm going to put a dot here at 8. Then was it 16? Yeah. 16, 22, 34, 62. Okay. I like that question mark. Oh, darn it. I didn't plan ahead for this, guys. Whoops. So just have a dot out there for me, will ya? Even though I know that's not quite where it would be, I apologize. Now the question is, well, what about the whisker? So what you do in this case, when you are disjointing one of your data points because it's an outlier, your whisker extends to the next one. So the next one, if I recall, is it 41? Was the next data point?
4, actually.
Oh, it was 44? No, 4.
Side of my paper, my bad. Dude, I got you. You were right. It was 34.
41. So this
No, it was 34. Q3 is 34.
No. The original data.
Oh,
So if I'm excluding,
yes,
yeah.
41.
I'm sorry if I'm not being clear, guys. So what I did, because this is a dot all on its own, this is where my whisker extends to. Okay, I'm sorry if I wasn't being clear on that.
I got you.
Yeah, okay. Sorry about that. So what we've made here, this is called parallel box plots, okay? And basically parallel box plots are just a way to compare two sets of data in a box plot form. There's one other thing we need to do here though, okay? When it comes to parallel box plots, don't I need to know which is which? Right? So here, another addition when you're doing parallel things, you need to make sure that you're labeling this one was Aaron and this one was Todd. Okay, you have to indicate which graph is which. Again, it's wrong if you don't, because you do have to be clear at what's going on here. Okay, is everybody still with me? Everyone good? Yeah? All right. What? Oh, okay. All right. Shh. All right. So now let's talk about comparing these. Box plots have some very interesting topics when it comes to comparing, okay? Again, for comparisons, you don't need exact values anymore, right? You're just comparing which is higher, which is lower, stuff like that. So let's run through socks really quickly, and then I'll kind of show you what it looks like in written out form. So socks, we're going to start with shape, okay? What shape did we say that this was? Aaron was skewed left, right. We saw a lot of extra spread down here, indicating that there's a little bit of skewness there. I think Todd's is much easier to see. What shape is Todd's? What? Um, I would agree with you, except there's one huge factor that's going to change that. Yeah. So they're opposite in nature, right? Opposite in shape. Aaron is slightly skewed left. Todd is skewed right, and again, I think that's easier to see because of that outlier. O is really obvious, right? The outliers. We definitely have a high one for Todd. Aaron doesn't have one. Um, Center. Which one has a higher center? For sure, Aaron, right? Aaron's median is up at 34. Todd's was 22, if I recall. Spread. Now, this is where I like some of the conversations we can have here. Okay? There's two versions of spread that we could discuss. Okay? So, spread up to this point has always meant range, right? Min up to max. Which one has the higher spread? Todd, because of that outlier, right? That's drastically increasing that range. But yesterday we talked about a different version of range. What did we talk about yesterday? Interquartile range. Yeah, that. So, so, so now interquartile range also has a very visual representation. Interquartile range, Q1 up to Q3, isn't visually your interquartile range. Isn't that just the box itself? Right? So you have a visual representation of both. Visually, you're either talking about the whole thing or you're talking about the box. Now, I made this one specifically to be interesting because if you check the math, I made the interquartile ranges actually exactly the same thing. Okay? So this is where you want to start being very clear what you're talking about. If you're talking about range, Todd obviously has a higher range, right? But if you're comparing interquartile ranges, now you're talking about two things that are actually exactly the same thing. Okay, so you want to start being clear on which one you're referencing because spread is a very generic term. You get to choose a specific one that you reference. Does that make sense? That you want to be clear on which one you're talking about? You can't just say the spread is bigger or they're the same because you have to say what you're comparing about the spread, range or interquartile range. Does that make sense? Yeah? All right. So let me show you what I put. Sorry. Sorry, guys. Oh, there's a good chance I can start passing stuff back. Uh, I mean, it's good to have answers down in notes. I I try to be right. It's kind of my job. What? Yes. You can paraphrase. So one thing is if you have a shorthand you can write in, but you understand like on the AP exam, this is what you'd want to put. If in your notes you have a shorthand for yourself just to be more efficient, as long as you know that on my tests and on the AP exam that this is the expectation, I'm okay if you summarize in notes. Just again, as long as you're fully aware As, oh, whoops. I think it's right there. Is that for me? Love it. Thank you. I love getting work from kids. You're welcome. All right. One thing I want to discuss. While you're writing. Shh. Shh. One thing I did want to throw into the conversation is the question. The question was compare. That's why we're doing socks plus context. But then also, deeper in the conversation, which player has the better home run records? So that's what this paragraph is more getting at. So that's why I dove deeper than just socks. Because to compare, if you think about it, didn't Aaron have the higher median and the higher minimum? And aside from the outlier, wasn't his maximum also higher? So if you think about it, while Todd had one thing that was better, he did have that one outlier. In general, though, who was better? Despite that one outlier. Aaron. Yeah, I think Aaron was better overall. Oh, I'm sorry, Hank or Aaron, doesn't matter. Yeah, I shouldn't give people two first names. That's confusing. Yeah, I think I made Todd up, didn't I? I think. I made that data to specifically have an outlier. So it doesn't make sense where this conversation is coming from, because this is answering the question who would be classified as better. Oh wait. Oh, sorry. Okay. I'll say I'm starting to get this all mixed up. Okay. By the way, I loved how thorough your stuff was. That was magical. Is anybody still writing? Does anybody need more time? Okay, so it's okay to keep going? All right. All right. Shh. Guys. Shh. So the other interesting thing. Now, I wrote this in for you because you don't have to include it in the conversation, but this does lead to some good multiple choice type things, which is why I want to address it here. So, if you notice, another interesting fact I made was I made these two things the same, right? Weren't these both sitting at 34? So, what that means is half of Aaron's home run hits were above 75% of Todd's. Can everybody see that comparison there? 50% of his data is above a whopping 75% of Todd's. So again, when those line up nicely, those can lead again to some interesting conversations happening, especially multiple choice. I wouldn't expect you to put that as an FRQ, but you might have to recognize some features like that in terms of a multiple choice question. Okay, and then the very bottom of that page addresses what I already talked about earlier. Um, the the whole thing that the length of the segments has nothing to do with the amount of data in there. It's solely how spread out is that data. Every segment represents 25%. Okay. So any questions so far? No? All right. So, every 17 years, swarms of some cicadas emerge from the ground in the eastern United States, live for about 6 weeks, and then die. There's several broods, so we experience the cicada eruptions more often than every 17 years. There's so many cicadas that their dead bodies can serve as fertilizer and increase plant growth. In a study, a researcher added 10 cicadas under 39 randomly selected plants in a natural plot of American bellflowers on the forest floor, leaving other plants undisturbed. One of the response variables measured was the size of the seed produced by the plant. Here are the box plots and summary statistics of seed mass in milligrams for 39 cicada plants and 33 undisturbed control plants. Based on the graphical displays, which distribution has the larger mean? So which one had the larger mean? Because what do you notice about the medians? The medians are exactly the same, but the shapes give an idea as to what's happening to the mean, right? So we don't know exactly what the mean is. This one is being pulled which direction? Left. So this mean is smaller. And where's this one going to get pulled? Right? It's going to get pulled higher. So which group has the higher mean? The one with the cicadas, okay? The cicada group had a higher mean than the control group. Oh, am I passing this back wrong again? Oh, yeah. Everyone should be getting two things back if you turned in two things yesterday. Again, I'm sorry if I'm messing this up for anyone, because some of these are out of order. All right. So, next, do the data support the idea that cicadas can serve as fertilizer? Give graphical and numerical evidence to support your answer. All right, so do we think that this works? Do we think that the cicadas are helping the plant growth? Yes. Why? Can you back that up for me? Bingo, yeah. So in part A, we discussed that the average is higher for the cicada group than the control group, right? Indicating that, yeah, it is increasing plant growth. There are there's other ways you could discuss that too. Didn't the cicadas increase the minimum and the maximum value for the size of the seeds as well? Wasn't literally almost everything pushed up except the median, to be fair? So you could talk about the mean being increased, or also it seems to have increased the minimum and the maximum values as well. So you could address any number of those things. Preferably the more you address, the better. So if you guys could fill in B for me. Love it. All right. So I think again this might be a good place to cut off. Tomorrow we'll finish this and do the review. We should have time for all of that.
You're like this.
Thank you.